Hello and welcome to another one of these ADD videos. Today we're going to be looking at some intermediate examples of assigning oxidation numbers. So I'm not going to go in as much detail. I've done it in the concept video as well as the basic example video in detail. Remember these rules, remember these hierarchies. Okay. So if I'm looking at CO2 was the first example, there's no fluorine, no alkali metals, no alkali earth, but oxygen is present. So we put a -2 for oxygen, and we know that we have two of them. So times 2 is a -4. So then we put carbon as a +4 to balance out that negative sign that I did not write. So that means the oxidation number for oxygen is going to be -2, and the oxidation number for carbon is going to be a +4. All right, here is our first example of a contradiction rule. If you look, beryllium, you remember beryllium, it's in group 2A, so the charge is +2. But hydrogen is also on this list. So what you have to do here is you have to compare where beryllium is on this list to hydrogen. Well, group 2A is above hydrogen, so the rule for 2A takes precedence over hydrogen's +1. In other words, the elements in group 2A more readily have the +2 charge than the hydrogen would have the +1. What does that mean to me? Well, what that means is when I'm assigning the oxidation numbers, I don't start with hydrogen, I start with beryllium of a +2. Now, in order for that to occur and be neutral, what must I add to a +2 to get a 0? Well, don't forget it has to be twice that. So twice times something gives me 0. What is that something? Well, what you can do if you want is you can put an x there, solve the equation. So if you subtract 2 on both sides, you're going to get a 2x equals -2. Then if you divide 2 on both sides, you get x equals -1. What that told you is hydrogen, which normally we've been labeling a +1, has now become a -1. That's why I told you it's not necessarily going to be this charge that you see associated with these elements. So the oxidation number of beryllium is a +2, and that of hydrogen is a -1. All right, so we have our first ion, polyatomic ion, chloride ion here. And this chloride ion, when we look at our list, well, first things first, we should start off by saying it has to equal a -1. All these up until now have had to equal 0, right? In this case, it equals -1. So, only thing on this list here is the oxygen and the -2. So I put a -2, and I know it's 2 times it because of the subscript of 2. So I ask myself, what do I need to add? Again, I'll label it as X, to what I have now to get a -1 charge. So just solve the equation at this point. We're going to multiply in order to get the x minus 4 equals negative 1. Then if you add 4 to both sides, you're going to get x equals a positive 3. So the oxidation numbers for chlorine is going to be a plus 3, and for oxygen, a minus 2. All right, you can see they're getting a little bit more tricky, and they can get even more trickier than that. So practice, 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 and do more practice until you can do them without missing any of them. You can do 5, 10 in a row, complex ones. All right. I hope I've eliminated any doubts you might have. Thank you and have a nice day.